So these are the types of problems that we do in assignment topic. The number one is balanced problem. Then we will do some unbalanced problems. Then restricted problem. Then maximization problem and tracking sequence problem. So more or less, these are all the types of problems that that has been covered in assignments. So let us start our session with an introduction of assignment. So what types of problems that has been asked in assignment? We will try to understand this this thing in this slide. So what is the meaning of assignment? Assignment means assigning jobs or tasks to the machines, assigning jobs to machines, tasks to workers. Okay, and the objective of this assignment is to minimize cost or time. Okay, so that we can get an optimum solution for this assignment, right? So let us understand this with an example. Let us suppose there are 5 men at the work. They are A, B, C, D, and E, and there are 5 types of machines available in the factory. So these are the machines. So now each worker can operate all of these 5 machines, but with varying efficiency. What does this mean? It means that maybe possible A takes 8 hours at machine 2, and he takes 10 hours at machine 4. Similarly, we take only 6 hours at machine 2, but it takes 13 hours to machine 4. So for each of the 5 workers with varying efficiencies working at each of these 5 machines. So assignment problem gives us an optimum solution for assigning these workers to the machines. Okay, so this thing will be more clear when we will do the questions. So first of all, let us start with the method, the procedure, basic procedure that we follow in assignment problems. Okay, basic procedure. So the problem structure is like a form of matrix of n into n order, or maybe n into n order, it depends. So what would be the step, and the question would ask, find the optimal solution for assigning, right? So what will we do? So our step 1 would be row reduction. It means we will the structure would be like this, right? So what is row reduction? Row reduction would be we will select a minimum smallest value from each row, and we will subtract that value to every other value in the row. So this is row reduction, and we will do for all the rows. This is row, this is column, right? And the step 2 will be column reduction. The same thing that we did for row, we will do now for the columns. We will identify the smallest value in the particular column, and we will subtract rest values from that value. So by doing this, we will get an opportunity matrix. Okay. After that, the step 3 would be we will make sure to cross all the zeros. Okay, by drawing minimum number of vertical and horizontal lines, right? So this will be the step 3. And how we will do this drawing of minimum number of vertical and horizontal line? We will do row scanning, then we will do column scanning, and there is a specific method of how to do it. So the method is we will find out the smallest value in that particular. We will find out if there is any single zero. Then we will mark that 0, and then we will then make the alternative column line for that particular row, as well as for column 2, we will make the same thing for the row. Okay, so this is the third step. Now let me erase this. So step 4 is now there can be two cases. Now step 4 is, if number of lines that we draw is equal to order of matrix, then optimum solution has been arrived. Then there is case 2, if number of lines is not equal to order of matrix, then we will move to step 5. Okay, in step 5, what we will do, we will identify the smallest uncovered value. Identify, once again, we will identify smallest uncovered value, and then we will subtract it from all the unassigned value, from all the uncovered value, and we will add this value to the crossing point of the lines that we draw for rows and columns. Okay, so all of this sounds so theoretical, but when we do the question, then we will try to understand what is happening actually. So after that, we will again repeat step 4. Okay, and then we will try to find the optimal solution. So more or less, this is just an introduction of what is the basic procedure for assignment problem. Now, let us now jump to the questions in the next slide. Okay. So, question says that Web India has 4 web projects to complete and 4 workers with varying degree of expertise in web development for a particular industries. Okay. Estimation of processing time for each project by each worker are shown below in the table. Development time cost as an average of $100 an hour. Assign each worker to a project so that cost is minimized. Okay. So let us try to do this. So our first step is we will make our own matrix 10, 5, 6, 10, 6, 2, 4, 6, 7, 6, 5, 6, 9, 5, 4, 10. Okay, so what question is saying that Brajesh spends 10 hours for project 1, Brajesh takes 6 hours for project 3. Naman takes 6 hours for project 2, Naman takes 4 hours, 6 hours to project 4. We will try to assign these projects to all 4 of them based on this information, and we will try to minimize cost, which can be evaluated in terms of hours. Okay, so our step 1 is row reduction. Okay, so what will we do? What is the smallest value here? Let me change the pen color. The smallest value is 5 for the row. The smallest value is 5. So let us first do the row reduction. We will subtract this 5 from all of these numbers. So 5 minus 5 is 0. 5 minus 6 is 1. 10 minus 5 is 5. Okay, we will only take positive values. Okay. Now we will again identify smallest value, and we will do the same thing for rest of the rows. So here it is 2, 4, 0, 2, 4. The smallest value here is 5, again 2, 1, 0, 1. Okay. The smallest value again here is 4. So 5, 1, 0, and then 6. So this is our step 1. Now what is our step 2? Our step 2 is column reduction. Okay. So step 2 is column reduction. Okay. So again, we will identify the smallest value here. The smallest value is 2. I can straight away write 5 minus 2, 3. 4 minus 2, 2. 2 minus 2, 0. 5 minus 2, 3. Okay. Smallest value is 0. We don't need to do additional maths. Smallest values again is 0. 1 minus 0 is 0. 1. 2 minus 0 is 2. 0, 0. Smallest value here is 1. Again, we will do 4, 3, 0, and 5. So this is our opportunity matrix. Opportunity matrix. So the first two steps are clear. First is row reduction, second is column reduction. Then we will move to our step 3. Okay. Step 3. What is step 3? Okay, so now we will try to assign values. Let me first put it here: 5, 0, 1, 5, 4, 0, 2, 4, 2, 1, 0, 1, 5, 1, 0, 6. Now we will try to draw lines here, minimum number of lines, so that we can cross all the zeros that are available. Okay, so how can we do it? Please pay attention. How do we do it? We will first do row scanning. Okay, first we will do row scanning. What is row scanning? Row scanning here is we will try to identify single zeros. We will try to identify those rows which have single zeros. Let us do that. So first row here is a single zero. Let me change the pen color first. Okay. So let me mark this 0, and I will cross all the corresponding column members. Right? This is what I know. What I did, I crossed all the corresponding column members. Let me go to row 2. Where row 2 there is no 0. I will move to row 3 then. For the row 3 there is 1 0. Let me mark this 0. Okay, and I will cross the corresponding column. Right? Then again I will move to row 4. These two has already been crossed, so there is only 2 numbers and there is no 0. So my row scanning is complete. What is the second? Second is column scanning. Okay, we will do the same thing for the column. So there is a first column, there is no 0. I cannot assign anything. For the column 2, it has already been crossed. For the column 3, it has already been crossed. Okay, so these are the things that we did. Let me erase this. So I did all this wrong. You know why? Because I just copied this and not this. So please erase step 3. Right? This is step 2, and I need to do all the operations on this, not this. So this was the mistake. So let me again do the code process. First 3, 0, 1, 4, 2, 0, 2, 3, 0, 1, 0, 0, 3, 1, 0, 5. Okay, so this is step 3. I need to do all the operations here. So again, let me do similar operations. So here only 1 0. Let me mark the 0, and I will cross the corresponding column. Okay. Here there is no 0. Here there is 3 0. I will not mark any 0 because there are 3 0, and I am unable to assign. I will assign only those numbers that where I can find only single 0. Okay. Here is only 1 0. I can assign this, and I can straight away cross this. Again, I will do the same thing for the column. For the column, in the first column, I can assign this 0 to this particular person, and I can straight away cross this particular row. For this column, all the zeros has been crossed, so I cannot further reduce this. Okay. So now let me check the step 4. So what is step 4? Step 4 is okay. I have to check for order of matrix. Is it equals to number of lines that I drawn? No, I have already drawn 3 lines and order of matrix is 4. What is order of matrix? Number of rows and number of columns, right? So it is 4 into 4 matrix and I have drawn only 3 lines. That is why my optimum solution has not been reached. My optimum solution has not been reached. Okay. So let me erase first some. Okay. So what is the next step? So next step is step 4. I'll move to step 5. The step 5 says that first I have to look for all the unassigned numbers, which are 3, 2, 3, 4, 3, and 5. And then I have to take smallest value from all these assigned values. From the all of this assigned number, it will be my x. And x there is 2. You can see 3, 2, 3, 4, 3, 5. 2 is the smallest value. Okay, so what will I do with this 2? I will subtract this 2 from all the unassigned values. What are the unassigned values? This is unassigned value, this is unassigned value, this. I will subtract 2 from all these unassigned value and I will add this 2. I will add this 2 of, on all the junctions of these lines. These are the crossings for these 2 lines and I will add this 2. And I will not change. I will not change all the values that has been except these 2, all these values that are under the lines, right? So what I did, let me again say this. First, I have identified smallest value from all the unassigned value or all the unhighlighted portions, and that is 2, right? So from 2, I subtracted all the unassigned values. Then I add this 2 on all the crossings which are 1 and 0, and I have not make any addition or subtraction to all the other highlighted terms. Okay, so what will be my matrix will look like? Let me take here. Which is my step 5. Step 5 continues here. Okay, so 2 is the term. So let me minus 2 here. 1. I will not make change on 0. I am going through this 0. For this one, again I will not make change. For this 4, I will make this 3. Right? For this 2, it is 0. Then I will not make change. Then this is 2. Then this will be 2. Okay. So let me do this. Okay, I have to subtract 2 here. So this will be 2. Sorry. Yes. And this will be 1. Right? Now for this 0, I will add this one number here with the 2, which is 3. Okay, I will again make addition of 2 here. This is 2. I will not make change here. Okay, 3 minus 2 is 1. Okay, this is 1. Okay, so this is 0. I will not make change on for these 2 terms. 5 minus 3 is 2. Okay, 5 minus 2 is 3. Sorry. Right. So let me first multiply here. This is 2. This is 1. So, and this is 3. Okay, so this is my step 5. Now I will move to step 6. What is step 6? Repeat row scanning and column scanning. So what I did in step 3, I will repeat again for this step 5. Okay, so for the first row there is 1 0. I can assign this and I can straight away cross all the zeros, right? All this column. For the second, I can assign this and I can straight away cancel this column. Okay. For the third row, these 2 have already been crossed. There are only 2 days, so I can assign this here and I can straight away cross the column, right? For this, I can, it is only a single 0. I can assign simply here and I can cross 0 here. Okay. So this is what this matrix look like. Project 1, project 2, project 3, project 4, right? So what does this imply? It implies that I can assign project Rajesh to project 2. Okay. I can assign Kalki to project 1. I can assign Naman to project 4. I can assign Chris to project 3. Okay. So we have all the hours these 4 people take on these different projects, right? So Brajesh take 5 hours in project 2, and then Kalki takes 6 hours on project 1. Then Naman takes 6 hours on project 4. Okay. Then Chris takes 4 hours on project uh, 3, right? So what is the cost here? What is the total number of hours that it takes? Which is 12 plus 4, 16 plus 21. And what is the cost per hour? It is $100. So the minimized cost is $2,100. Okay, so what does this mean? That if we assign Brajesh, Kalki, Naman, Chris to these projects, we can minimize the cost the maximum, and that is $2,100, right? So this is the whole question. So what we did here, okay, so first we did row reduction, then we did column reduction, then we look for the then we cross all the zeros as much as we can. Then we compare the order of matrix with the number of lines, and then if it is not equal, then we move to step 5, and where we subtract the lowest unassigned value to all the unassigned values and then add it to the process, and then not change the highlighted lines. Okay. Then we again repeat the row scanning and column scanning, and we are able to make the optimum solution. Okay. So we are more or less going to do the same thing for all the questions that we do with few variations. Okay, we will discuss the variation as the question comes. Okay. Let me move to the next question. Okay, the next question says, and it is the same type of problem. These are called balanced problem. Why they are called balanced problem? Because number of columns is equal to number of rows. So this is the condition for balanced problems. Okay. So fibrous incorporation makes product from rough tree fibers. Its product line consists of 5 items through one of the 5 machines. A, B, C, D, E are the machines. These are the products. The machines are not identical, and sub-products are better suited to some machines. Given the following production time in minute per unit, determine an optimum assignment of production product to machines. So minimum time, it is asking minimum time in which this project can be completed. This product finishing can be completed. Okay, so again we will do the same thing. First is the row reduction. First, let me the question here 10, 15, 16, 20, 12, okay. First, let us do the row reduction. The minimum values. So let me do this. 10 is the minimum value. 7, 0, 5, 6, 10. Okay. Here minimum value is 9, 3, 0, 7, 0, 5. Here minimum value is 11, which is 0, 5, 3, 4, 1. Okay. Here minimum value is 10, which is 4, 0, 0, 8, 7. Here minimum value is 9, which is 4, 3, 0, 6, 2. Okay. So this is row reduction. Now we will do step 2. Step 2 is column reduction. So first column minimum value is 0. We can straight away write 7, 3, 0, 4, 4. In second row minimum value is 0. Again we can straight away write 0, 0, 5, 0, 3. In the third row again minimum value is 0. So we can straight away write 6, 0, 4, 8, 6. In the last column minimum value is 1. So 9, 4, 0, 6, 1. Okay, so this is our opportunity matrix. Now we can go for the step 3. Step 3 is we will try to draw the crossing all zeros. So we will try to cross all zero by drawing a minimum lines. And how to do it? If there is single zero, we will assign that zero and we will cross the corresponding column. Okay. If there is single zero, yes, there is a single zero. You can assign this. I can say that we cross this. In the third row, there is two zeros. I cannot do that. In the fourth row, there is no zero. In the fifth row, there is no zero. Okay. Now I am going for column scanning. Okay, row scanning, column scanning. So in the first row, there is 1 0. I can assign this 0 and I can straight away cross the corresponding row. In the second column, already crossed. Third column, already crossed. In the fourth column, there is no 0. So let me. So what is my step 4? Okay, I've made 7 0. So I forgot to write this particular row here, right? So let me write this row again. Okay. So what is this row? I forgot to write this row, right? So 5, 7. Again, there is a 0. I can straight away write like this. 3, 0, 0. Okay, then again I have to do all the progress. Okay, so let me do again this. So step 2 is column reduction. What will we do in column reduction? First row there is 0. So we can straight away write like this. 7, 3, 0, 4, 4. Again 0, 0, 5, 0, 3. This 5, 7, 3, 0, 0. This 6, 0, 4, 8, 6. And again smallest value is 1, 9, 4, 0, 6, 1. Okay, now we will do the same thing. Step 3. Crossing all zeros. Corresponding column is crossed. 1 0, I can mark this. Corresponding column is crossed. 2 zeros, I cannot do anything. 1 0, I can again mark this and cross the corresponding column. There is no 0. Okay, in the last row. Now for the column 1, there is 1 0. I can mark this and cross the corresponding row. For the column 2 already crossed, column 3 already crossed, column 4 already crossed, column 5 there is no 0, so I cannot do anything. Order of matrix is not equals to number of lines here. As you can see, order of matrix is 5 cross 5, which is 5, and number of lines that we draw is 4. So we will move to step 4. Okay. So step 4 says. Step 4 says that I need to look for the smallest value, smallest unassigned value. And what is the smallest unassigned value? Is 1. Okay, so I have to subtract this from all the given terms here. Let me write this question here. Okay, so step 4. Let me subtract this term from all the unassigned terms, which is 6, 2. 0 will be remaining unchanged. 3, 3. 0 will remain unchanged. 0. Now 5 is a crossing, so we will add 1 to 5. 6. Again, we will not change 0 and 3. Okay. So column 3, 5 will not change. 7 will not change. 3 is again a crossing, so we will add 1, 2, 3. 4, we will not change 0, we will not change 0. For the column 4, 6 will not change, 0 will not change. For the 4, we will add this 4 here. Okay, and we will not change 8 and 6. For the column 5, we will subtract 1 from all the unassigned terms, which is 8, 3. We will not change 0, 5, and 0. Okay. So what is step 5? We will do again row scanning and column scanning. Okay. So step 5 will be right here. Okay. So in the first row there is 1 0. Let me assign this 0 across the corresponding column. Okay. For the second row there is 1 0, and I can assign this 0 and cross the corresponding column. For the third row again there is 2 0. For the fourth row again there is 1 0. I can assign this 0 across the corresponding column. Okay. For the last there is 1 0. I can assign this 0 here and I can cross the corresponding column. Okay. Now column wise scanning. First, in the first column there is 1 0. I can assign this 0. I can cross the corresponding row. Okay. For the second column, it is already crossed. Third, fourth, 5 already crossed. So let me check all the values have been assigned or not. Okay. So as you can see, for the product 1, machine D is assigned. Okay. For the product 2, machine D is assigned. Okay. For the product 3, machine A is assigned. Okay. For the product 4, machine 3 C is assigned. For the product 5, machine E is assigned. Okay. So all the machines have been assigned, and our order of matrix is 5, and number of lines that we draw is 5. So it means our optimum solution has been reached. Remember, this condition must satisfy. This condition must satisfy. This condition must satisfy that order of matrix should be equals to number of lines that have been drawn. Okay, then only you can say that optimum solution has been reached. So here we can see 5 lines have been drawn. The order of matrix is also 5. Means that these are the assigned terms in the minimum time, and so the time it takes. What will be our answer? Okay, so 10 hours. Product 1 will take 10 hours for machine B, plus product 2 will take 9 hours for machine B. Product 3 will take 11 hours for machine A. Product 4 will take 10 hours. Okay, and then product 5 will take 11. So this is the answer, which is 19, 30, 40, 51 hours. Okay, so this is the minimum time, 51 minutes. This is the minimum times that this project will take. Right. So I believe now method must have been clear to you guys. If it is not clear, then no worries. We are going to make same. We are going to apply same concept with slight variation for the further questions. Okay. Okay. Now unbalanced problem. So why it is called unbalanced problem? Let me first tell you that. So till now we have do 2 questions in which number of rows were equal to number of columns. But now, as you can see in this question, there are 3 types of jobs and there are 4 machines, which means rows are 3, columns are, these are rows, columns are 4. Okay, so that is why they are called unbalanced problem. So what is the method to do it? So before our step 1, what we do, we will do a slight change here. So we will add one dummy job, and we will assign 0 cost to all the machines. So in the question there were 3 jobs and there were 4 machines that can each job takes different cost for all the 4 machines. So what I added simply one row which is called dummy row, and I have assigned 0 cost to each of the machines. So why I was able to do it? Because I have assigned 0 cost, so it will not make any change, but it will provide mathematical simplicity to solve this question. because now we have 4 into 4 matrix and we already know how to solve 4 into 4 matrix questions. Okay, so if there is any question that comes which is unbalanced, what you need to do, you will always need to add dummy for the corresponding row, for the corresponding column, wherever what is necessary, right? So let me now solve this question with our method. Again, what is our step one? Our step one is row reduction. Okay, so let me first reduce the row. So as you can see, minimum value here is 10. So 2, 6, 4, 0. Okay. Now minimum value in this row is 8 is 7. So 2, 1, 6, 0. Minimum value in this row is 9. So which is 6, 3, 0, 2. Okay. So in this row, what is the minimum value? 0. So we will straight away write 0 minus 0 is 0. Okay. For the column, we do not need to do mathematical calculation. Why? Because there is a 0, and every number should be subtracted from the smallest value. So our step 2 will be the same as step 1, and we can straight away write 2, 2, 6, 0, 6, 1, 3, 0, 4, 6, 0, 0, 0, 0, 2, 0. Why I was able to do it? Because I have to subtract all of these numbers from the minimum value in that particular column, and that is 0. So 2 minus 0 is 2, 2 minus 0 is 2, 6 minus 0 is 6. Okay, so this is my step 2. What is my step 3? My step 3 is crossing all the zeros, by drawing the minimum number of lines, right? So step 3. As you can see, there is 1 0. I can straight away assign this 0 here, and I can straight away cancel this column. In this there is no 0. In row 3 there is 1 0. I can assign this 0 here, and I can straight away cancel all this column. So you guys must be able to now understand that why I was able to cross this column, because corresponding job has already been assigned to the machine C. Okay, that is hit and trial. That is what I'm trying to do, right? That is why I'm crossing corresponding column. So for the row 3 there is no 0. For the row 4 there is 2 0. So I will not make any further reduction, any further lines in row scanning. Now I will do column scanning. So for the column scanning, I can see there is 1 0 here. I can assign this 0. I can cross this line like this. In the second column, I can see there is no 0. I cannot do anything. For the third and fourth column, they have already been crossed. Now let me check step 4. Order of matrix is equals to number of lines. So order of matrix is not equals to lines. Right? As you can see there, we have drawn only 3 lines, and order of matrix is 4. So I will have to do step 5. Okay. So step 5. So what is step 5? I have to look for the smallest value from all of these terms, and that is 1. And I have to subtract this one from all the unassigned terms. 1, 1, 5, 0, 5, 0, 2, 0, 4, 6, 0, 1 is added to this 0, which is 1, 0, 0, 2, 1. Right? So what I did, I took the smallest value, I subtract this from all of these unassigned terms. I did not change these terms which have been underlined, but I add this term in the junction points where vertical and horizontal lines are crossing each other. Right? So this is my matrix. What will my step 6? My step 6 repeat step 2, repeat step 3. I will again do row scanning and column scanning. So as you can see in the row, there is 1 0. I can assign this corresponding column. Here I can see there is 1 0. I can assign this 0, and I can cross cancel this column. For the third row, there is 1 0. I can assign this 0. I can cancel this column. For the fourth row, there is 1 0 left. I can assign this 0 here, and I can cancel all. So now what will I do? I will check the order of matrix with lines, number of lines that have been drawn. So as you can see, there are four is the order of matrix, and number of lines that I have drawn is 4. So optimal solution has been reached, and we were able to assign all the we have assigned all the job to the particular machine. Okay, so what would be my answer? Okay, so I'm writing answer here. Okay, so job 1 is assigned to B, job 2 is assigned to B, job 3 is assigned to C, job 4 is assigned to A. Okay, now for job A is assigned to, sorry, 1 is assigned. So 1 has been assigned to D. Okay, 2 has been assigned to B, 3 has been assigned to C, 4 has been assigned to A, right? So what does this mean that 4 has been assigned to A? It means that job machine A will remain idle, right? As you can see, there were 3 jobs that has been assigned to that needs to be assigned to 4 types of machines. Okay, so all the 4 machines are able to do all the 3 jobs. So, but since there are only 3 jobs, one machine has to be idle. So that machine which has been assigned to the dummy job, that means it will remain idle. Okay, now let me calculate the cost, which is 10 plus 8 plus 9, right, plus 0. So this is the cost. So what will be the cost? 27 is the cost of assignment, minimized cost for this assignment, right? So this is the type of unbalanced problem. Now let us move towards the next type of problem, which is a restricted problem. Okay. So what does this mean, restricted problem? It simply means that there are some types of jobs, or there are some types of workers that are not able to perform a particular. There are some types of machines and some type of workers that are not able to perform a particular job or a particular task. Okay, so we are not allowed to assign that particular task to a worker as well as that particular job to a machine. The question will explain this thing, that in a plant layout there are 4 different machines: M1, M2, M3, M4, and they need to be erected in a machine shop. Okay, there are 5 vacant areas A, B, C, D, E. Because of the limited space, machine M2 cannot be erected at area C. Okay, so let me write here is infinity. I will tell you why I am writing infinity here later. At machine 4, it cannot be erected at A. So machine 4 cannot be erected at A. Right? The cost of erection of machine is given in the table. Find out the optimum assignment plan. Okay. So it says that machine 2 size is a little big, so it cannot be go to a place C. Okay, area C. And machine 4 cannot go to area A, right? So what I will do, okay, I will assume that the cost of doing this particular thing is infinity. The cost of erecting machine 2 at C is infinity. And why are we using infinity? Because of calculation simplicity. You will see that this infinity will make the calculation more simpler. We can also assign in many places. You will see that that question will say you can write M here or high cost here, but do not use M and H. It will confuse you while solving the question. So always use infinity here. Okay, so let me assign infinity here. Now again, this question has one more twist. We can see that there are only 4 machines and there are 5 areas which needs to be erected. So what we can do now, okay, we know what we can do now. We can assign a dummy machine, okay, with a cost of 0 to each of these areas, and we can straight away solve this question. Right, so this question is a good question because it has 2 variations. We have to first use this infinity and then dummy. So how can we solve these questions? Let us try to find out. Because we will use the same procedure. Okay, no worries. So our first step is as always, which is row scanning. Okay, so let me do the row scanning. The minimum value is 4, which is 4 here. So 0, 1, 5, 0, 1. Okay, now minimum value here is 3, right? So 3, 1. Infinity minus 3 will be infinity. 4 minus 3 is 1, and 3 minus 3 is 0. So now you must understand why I use infinity, because if I write n here and while solving the question, I will stuck what will I do with n minus 4? Okay, so these things will create confusion. Always with infinity, so you can simply use mathematics, because we know infinity minus 3 is infinity, right? Okay, for the machine 3, the smallest value is 1. So 3, 4, 7, 4, 0. For the machine 4, what is the minimum value? 1. Infinity minus 1 is infinity. 2 minus 1 is 1. 6 minus 1 is 5. 1 minus 1 is 0. This is 1. Right? So this is what will we do for dummy? We will simply write 0, 0, 0, because 0 minus 0 is 0. Okay. This is our step 1. This is row reduction. Now, let me move to step 2. Okay. Step 2 is column reduction. So there is 0 in the first column. I can simply write away like this. Infinity minus 0 is 0. In the second column again there is 0. Okay, so there is a dummy row, right? So we can all of these terms will be as it is. Since 0 is the smallest value, and we need to subtract all the terms from 0. Right? 1, 1, 4, 1, 0. 5, infinity, 7, 5, 0, 0, 1, 4, 0, 0. Okay, 1, 0, 0, 1, 0. So this is my column reduction. This is my row reduction. Now, what is the third step? Third step is crossing all the zeros by assigning crossing all the zeros by drawing number of minimum lines. Let me write step 3 here. Okay, so as you can see, first row has 2 zeros. I cannot cross anything. In the second row, there is 1 0, which is this. So let me assign this and let me cross corresponding row. For the third row, there is no 0. For the fourth row, there is 1 0. I can assign this 0 here, and I can cross this particular column. Okay. For the last row, there is 3 0. There are 3 zeros. We cannot do anything. Now let us do column scanning. Row scanning we did it. Now we are going to column scanning. For the first column, there are 2 zeros. I cannot cross anything. For the second column, there is 1 0. I can straight away assign this and cross the corresponding row. Okay. For the third column, there is no 0. Okay. But now there is one more variation in this question. As you can see, 1 0 has been remained. 1 0 has been remained, which has not been covered. What will we do? We will again do row scanning and column scanning. Okay, so we will do row scanning and column scanning till all zeros are covered. Right? So I can again, for this row, there is this 0 has been remained. I can assign this 0 and I can set the corresponding column. Okay, now step 3 has been completed. Let me move to step 4. So in the step 4, I have to check for order of matrix with the number of lines that have been drawn. As you can see, order of matrix is 5 and number of lines that have been drawn is 4. So the optimal solution has not been reached. And I have to move to step 6. Okay, step 6 is smallest unassigned value. Remember this term. And this is x and subtract x to all others assigned. Okay. So let me change to let me make the next step 6 here. Okay, next matrix is here. So the smallest value here is 1. There will not be any change here. 0, 3, I'm doing for column 1, 0, 3, 3, infinity. This is a crossing. I have to add smallest value, which is 1. I have to subtract unassigned, which is 1 minus 1, 0, 0, 3, 0, 0. Okay, now for the third column, 4, infinity minus 1 is infinity. 7 minus 1 is 6. 5 minus 1 is 4. This is 0 because it is under the covered line. For this, 0, 1, 4, 0. This is a crossing. I have to add 1 here. Okay. I will not make any change here. 1, 0, 0, 1. I have to add 1 here also. So this will be my matrix. Next step will be I have to do again row scanning and column scanning. So first row scanning, there are 3 zeros. I cannot make any change. For the second row, there are 2 zeros. I cannot make any change. For the third column, there is 1 zero. Let me assign this. Let me cross this. For the third, there are 2 zeros. I cannot do anything. For the fourth, there is 2 zeros. I cannot do anything. For this column, there is 1 0. I can assign this and I can cross this row. For this, there are 2 zeros. I cannot do anything. For there is 1 0. I can straight away assign this and cross the corresponding column, corresponding row. For this column, there is 1 0. I can assign this and I can cross this straight away to this particular row. Now, as you can see, 1 more 0 has been left. So what will I do? I will do again row scanning and column scanning. Okay, and then 0 for this row, this 0 has been assigned. And first this row scanning, so I have to cross this column. Okay, so all the zeros have been covered, and I will move to the next thing. And the next thing is check for the order of matrix and the lines. The order lines. As you can see, order of this matrix is 5. Number of lines 1, 2, 3, 4, 5. So number of line is also 3. So optimum solution has been reached. Right? These are the corresponding assignments. Okay. So let me first use this eraser. So what are the assignments? So machine M1 will be assigned to area A. Okay. Machine M2 will be assigned to area B. As you can see, machine 2 cannot be assigned to area C, so it is good thing that it will be assigned to area B. Machine 3 is assigned to area D. Machine 3 is assigned to area E. Sorry. Okay. Machine 4 is assigned to area D. And machine 5 is assigned to area C. Right? So let me first erase this. So what would be my assignment cost? These are the cost that has been given. So time assignment cost would M1 is A, M2 is B, M3 is E, M4 is D, M5 is C. So A is 4 plus B is 4 plus C is 1 plus 4 is 1 plus it is 0. So this is 10. Right? What does this mean that dummy has been assigned to area C? It means that area C is vacant and no machine has been assigned to area C. Okay, so what we are simply following the same procedure for all the questions, but since there is some variation in the question, so we will common sense we will make small changes using our common sense, right? So again, let us come to the next variation, which is maximization problem. Okay, so till now we have done all the questions and we were trying to find out the minimum optimum minimum solution, right? Optimum solution for minimize cost or minimize time. So this is a maximization problem, and the name suggests here we will find the maximum possible cost that has been incurred. Okay, so what can be the cases? The question will describe the case. A marketing manager has 4 salesmen and sales territories. Considering the capabilities of the salesman and the nature of territories, the marketing manager estimates that sales per month are given like this in 100 rupees. For each salesman in each territory would be as follows. So these are the sales per month, estimated sales per month. Okay. Find the assignment of salesman to territory that will result in maximum sales. Okay. So if A has been assigned to 4,500 rupees would be the estimated sales. If A is to be assigned at 38, at territory 2, then 3,100 would be the estimated sales per month. Okay. So now it is asking about assignment of salesmen to the territories that will result in maximizing sales. Okay. So how will we do it? So we will use a very simple a matrix formula of maths, which says that if I subtract all of these terms, with the maximum value among these terms, if I subtract all of these terms with the maximum value, which is 45 here, if I subtract all of these terms with the 45 and then write all these terms here, this will convert into a minimization problem, and our minimization solution will be the maximization solution for this problem, right? So let me write here what I'm trying to say. So what will be my matrix, which will be our step 1 here? Our matrix will be 0, 745 minus 38. This is 15. This is 22. I will do the same thing with the second row. 10, 16, 25, 31. Okay. I will do the same thing with this row. 10, 16, 25, 31. I will do the same thing with this row. This is 18, this is 25, this is 30, this is 35. Right. So now the solution for this matrix, this is familiar. 1, 2, 3, 4. Matrix rule says the solution for this matrix, which would be minimized solution for this matrix would be the maximized solution for this given matrix, right? So now what we have to do is we simply need to do all the same procedure that we have learned, and we will find the minimized answer for this, which would be maximized answer for your question, right? So remember this variation, and now let me try to solve this. Okay, so step now again same steps. Let me write as predecessor step. Step 1 is row reduction. So 0, 7, 15, 22. It is simply 0, 7, 15, 22. 10 is the smallest term. So 0, 6, 15, 21. Here 10 is again the small terms. 0, 6, 15, 21. Here 18 is the smallest term. So I will write here again 0, 7, 12, 17. Right? Let me change the color. So it's step 2. What is step 2? Column reduction. So in the first column, I can straight away write like this. Okay. In the second column, 6 is the minimum term, which is 1, 0, 0, 1. In the third column, 12 is the minimum, which is 3, 3, 3, 0. Okay. What is the minimum term here is 17. So 5, 4, 4, 0. Right? So this is my column reduction, and okay, so it is actually 23, right? Regarding where it is not. because 45 minus 22 is 23, right? So this is 23, and this would become 6 then. There will be no change in the rows since row reduction is 0 has 0, and this would be 6. Where is this 6 here? Where is this 6? Okay. So this is my column reduction. What would be my step 3? My step 3 is row scanning, column scanning. To minimize, to cross all the zeros. First row there is 1 0, that means assign this 0 here to cross this. In the second, now this has been crossed, this is 1 0 left. I have assigned this and cross this row. In the third row there is no 0. In the fourth row there are 2 zeros. Now for the columns, for the first column already been crossed, for the second column already been crossed, for the third column there is 1 0. I can assign this 0 here and I can cross this 0 like this. In the fourth column now no 0 has been left. Okay. Number of lines drawn. Now I have to check with order with line drawns. Okay, order of the matrix is 4. Number of lines drawn are 3. So not equal. I have to move to step 5. Excuse me. So what is step 5? Step 5 is let me use pen color here. This color. Okay, step 5 is finding out the minimum unassigned value, which is 3 here, and then subtract this value from all the unassigned and add to the corresponding crossing points. Okay, so there will not be any change. So this is step 5. Okay, so there will not be any change here. This is 0 0 0. I have to add 3 at this junction. So let me add here. There will not be change. 0 0. I have to add 3 here since this is the minimum, which is 4. Okay. Now I have to subtract 3 0 0 0 0. I have to subtract 3 here 3 1 1 0. Okay. Now what will be in the step 6? Again do row scanning and color scanning and column scanning. Okay. So in the first column there are 2 zeros. I cannot do anything there. In the second column there are 3 zeros. I cannot do anything. In the fourth column, in the third column, in the third row. Sorry. In the third row there are 3 zeros. I cannot do anything. Same goes for the fourth row. In the first column 3 zeros. In the second column 2 zeros. In the third column 3 zeros. But in the last column there is 1 0. Right? And I can cross corresponding row. Okay. Now I will again do row scanning and column scanning. Okay. So in the first row there are 2 zeros. I cannot do anything. In the second row there are 3 zeros. Cannot do anything. In the third row there are 3 zeros. Cannot do anything. In the first column 3 zeros, 2 zeros, 3 zeros. So now one more variation that I am now going to introduce here. Okay, listen very carefully. Give me 1 second. Okay, so as you can see, and I can do n number of times of row scanning and column scanning. Still, there will remain these zeros. So what I will do here is step 6. Use red pen. Okay, so what I will do here is step 6 would be identifying diagonally opposite zeros. Right? So when condition arises where we are not able to cross all the zeros, so in that condition, the next thing that we will do, we will identify diagonally opposite zeros. Okay, and how can we assign those? Let us try to find out that. Okay, so this is step 6 that I am operating with the red pen. So in the first column there are 2 zeros, and then there is 1 0 here, and there is a diagonally opposite 0 at this point and at this point. So there are 2 diagonally opposite zeros. So if I assign this 0, okay, I have to assign another 0 which is diagonally opposite. Right? I can assign this and this also. Let me assign this here. Okay, so I have assigned these two zeros, and now we will do the same thing here. We will do the row scanning. So first row, I have already assigned this 0 here, so I can okay, so I can have to cross this column. For the second row, I have assigned this 0 already, so I have to cross this column, right? So what I did, I identified diagonally opposite zeros, and then I do the same thing, row scanning and column scanning. Step 7 will again row scanning, column scanning. Okay, now the third row, I can see that this is a 0 here. I can assign this 0. I can straight away cancel this column. In the fourth row, there is this 0, and I can cross this line like this. Okay, so this is actually the previous. I have just saved myself trouble by not making the new matrix. So what I did, I simply in the next step I simply copy all the column and rows, and I find out the regularity opposite. These were the regularity opposites, and these were also, but I did not use them. And I just simply make the row scanning like this and this, and then cross these columns, and then same procedure for this, crossing this, and then again come to this and crossing this. Okay, so now again I will check with order and lines. Order of the matrix here is 4. Okay, number of line here is 4. So optimal solution has been reached. Now I can assign A to 1 territory. I can assign B to second territory. I can assign C to 20 territory. Third territory I can assign D to 4th territory. Okay, but here when we are adding cost, we will go to our original question. We will not see this for cost calculation. Okay, let me again repeat what I did. When I was stuck where I cannot make more cross more zeros, what I did, I simply identify diagonally opposite 0, and then I assign those diagonally opposite zeros, and I do the same thing of row scanning and column scanning, according to which I have crossed first column and then second column and then third column and then fourth column, and then my optimum solution has been reached, right? Okay, so what would be the cost? Let me write the answer here. What would be the cost? Cost would be 45 plus 29 plus 20 plus 10. So this would be equals to how much? 64, sorry, 74, and then 94, and then 104 into 100, which is 1,400 rupees is my maximum cost that I can earn if I assign these salesmen to these territories. Okay, so you have seen now how maximize problem can be simply converted to minimize problem and solve accordingly. Okay, and the important step here is diagonally opposite 0. So let us now move forward to traveling salesman problem. Okay, so traveling salesman problem is a unique type of problem. Let me first write what types of problems there are from here. So let us suppose there are 4 cities, A, B, C, D, and there is a traveling salesman named Ram. Okay, so Ram is one of these cities, and Ram has to go to all the cities. Okay, which means he has to go to A, he has to go to B, he has to go to C, he has to go to D. Okay, so if Ram goes to A to B, if Ram is in A and he has to go to B, so there must be some cost, which is A. If Ram is in A city and he needs to go to C city, there may be some cost B. If Ram is in city and he first go to D city, then maybe some cost D. C. Accordingly, Ram cannot go to A city from A to A, right? Because how can person can go to the same city when he is in the same city, right? I cannot go from Delhi to Delhi, right? So I can simply write here is alpha, which will be changed from infinity when we solve this. We already know the concept of infinity. Okay, so give me 1 second, guys. Give me 1 second, guys. Okay. Okay. So accordingly, if he is in B city, uh, okay, accordingly, if he is in B city, he needs to go to A to B and C D, and there may be some cost of C, D, E, and he cannot go to B to B, so we will write alpha here, and accordingly, I can write alpha here. So this would be the problem structure of traveling salesman problem. Okay. Give me 1 second, guys. Okay, so this is the structure of traveling salesman problem. So as you can see, a person cannot go to the same city, right? So there must be some rules that has to be that one has to keep in mind while solving traveling salesman problem. And these are not rules; these are simply basic common sense which one has to be keep in mind while solving the question. So the first rule will be that going from A to A is not allowed, right? So A cannot get to A, B cannot go to B, C cannot go to C, D cannot go to D. Okay. So now, what would be the question in this note? The questionnaire would ask you that find out the best possible route with the minimized cost so that a RAM can cover all the cities. Okay. So we need to find the best possible case for that. Okay, so what we need to keep in mind are these rules. Rule 1 is going A to A is not allowed. What is rule 2? Rule 2 is no place to be visited twice. Okay, before going to all cities. It's a simple rule, right? If Ram goes from A to B, then again come from B to A, and then go from A to C. This will increase the cost, right? He has to cover all the cities in one go. Okay, so it is like if you are going in a school bus, the school bus will pick each student first, then go to school. It will not do this like if you pick one person, then one student, then go to school, then come for the second. Okay, because it is the very common sense problem. What is rule 3? So the third rule says that only that solution is optimal, which is again the implication of rule 2. Only that solution is optimal which complete the cycle. Okay, we have to complete the cycle to reach the optimum solution. So if you keep these 3 rules in mind, this is the same problem that we did till now with all the assignment problems. As you can see, we are using same procedure for all the questions with a slight variation according to question demand. Right. So let us move to the question. Okay. So question says that what should be the sequence of the salesman visit? Salesman is visited from these cities to all of these statement visited these cities. What should be the sequence so that cost is minimum? Okay. So again, it is a structure of assignment. So we will do the assignment thing. What would be our step 1? Step 1 would be similar. Okay, and again we will write infinity here for the alpha. Obviously, this is a hypothetical infinity, right? The cost should be 0, but we are using infinity so that we can simply solve this question without any problem, right? Okay. So Step 1 is row reduction. So what is the minimum value here? Minimum value is 1. So infinity minus 1 is infinity. This is 1. This is 4. This is 7. This is 0. Minimum value here is 2. Again 4, infinity, 1, 7, 0. Okay. So minimum value here is 4. So 4, 3, infinity, 0, 4. So minimum value here is 4, which is 9, 0, 3, infinity, 1. Okay, minimum value here is 1. So 0, 2, 1, 7, infinity. Right? So this is our row reduction. What is the second step? Second step is column reduction. So this column has 0, it will remain same. Infinity 4, 4, 9, 0. This column has 1, 0, it will remain same. 1, infinity 3, 0, 2. This column has no 0. Minimum value is 1, so 3, 0, infinity 2, 0. Okay, this column is 0, so 7, 7, 0, infinity 7. This column is 0, so straight away I should write 0, 0, 4, 1, infinity. Right? Let me change the pen color here. Okay. Step 3 is, what is the step 3? As we all know, step 3 is row scanning, column scanning, covering all zeros. First, there is 1, 0. I can straight away assign this 0 and cancel on the line. In the second line, there is 1, 0. I can assign this 0 and cancel this line. In the third line, there is 1, 0. I can assign this 0 and I can straight away cancel this line. In the fourth line, there is 1, 0. I can straight away assign the 0 and cancel this line. In the fifth line, there is 1, 0. Okay, I can straight away assign this line and I can cancel this column. Okay, so now what will be the next step? Next step is order of matrix equals to lines. So order of matrix is 5. Number of lines is 5. So optimal solution has been reached. Which means that from 1 to city it will go to 5. Okay. Then if it is 2, that will write 1, 2, 3, 4, 5, and that will write 1, 2, 3, 5. There is 1, 2, 3, 4, 5. So from 2 it will go to 3. Okay, from 3 it will go to 4. From 4 it will go to 2. From 5 it will go to 1. Okay. So what would be the next step? Is it the optimum solution? No, it will not be the optimum solution because we have to check for the rules, right? From 1 the salesman goes to 5, and from 5 it will again goes to 1, which means rule 2 has been, what is rule 2? No place to be visited before. Okay, no place to be visited twice, right? So rule 2 has been not applicable, which means this is not the optimum solution. Now again we will think with the logic. The logic says if salesman goes from 1 to 5, then again come to 1, obviously the cost will increase, right? So this will not be optimum solution. And what will be the next step is the new thing that we will try to understand here. So let me first write this matrix here. Infinity 1, 3, 7, 0, 4, infinity 0, 7, 0, 4, 3, infinity 0, 4, 9, 0, 2, infinity 1, 0, 2, 0, 7, infinity. Right. So now we know if we go with the zero value, we are not able to find the optimal solution because our complete journey is not happening. So what would be the next step? The next step would be choosing the next smallest value. Right. The next step would be choosing the next step smallest value. What is the next step smallest value? 1. So what is happening actually? We are simply iterating and trying. Okay. So if we are not using 0, let me assign here is 1 because it is the next smallest value. Okay, I cannot take the 0, right? So I can cross this particular column. Again, in this column there are 2 zeros. I cannot do anything. In this column there is 1 0. I can assign this 0 and I can cross this column. In the third row there is again 1. If we have already taken 1, we can again take that 1. Okay. So let me take 1 here and I can cross this column. In the fourth row there are 2 zeros. In the first column there is 1 0 in the last. I can cross this particular row. In the third column there is 1 row. There is 1 0. I can assign this 0. I can cross this particular row. Okay. Now what will I check? I will check with order of matrix with lines. Okay. So order of matrix is 5. What is the number of lines here? 5. So a number of lines are equals to number of order, which means optimal solution has been arrived. But since it is salesman problem, we have to again look for the logic, salesman rules, right? So what is happening? Let me write here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So from 1 it can go to 2. From 2 it is going to 3. From 3 it is going to 4. From 4 he is going to 5. From 5 he is going to 1. So I can see that rule 1 is applied. Rule 2 is also applied, that no place has been visited twice, and rule 3 has also been applied. Since if I add all this, it will be 1, 2, 3, 4, 5, 1. Right? So this would be my optimal solution. Right? So this is the traveling salesman problem, and we have to check for the rules. Always keep in mind, and those are not rules; they are simply some logics. Okay, so this is wholesome assignment problems, and these are the major variations that you can observe in assignment problems. Always remember that always stick to the basics. What is the basic method to solve it? There are also other methods to solve it, but do not confuse yourself with those methods. One method should be enough for the exam, and so these are all the problems that we have discussed today. Let me first calculate this cost, and then we will end the class. Okay, so my answer would be written here, which is 1, 2, 3, 4, 5. So 1 to 2. So 1 is going to 2. From 2 it is going to 3. From 3 it is going to 4. From 4 it is going to 5. From 5 it is going to 1. Okay. So what is my cost? Cost would be 2 plus 3 plus 4 plus 5 plus 1, which is nothing, plus which is but 5, 9, 14, 15. Right? So this would be my minimum cost for traveling salesman. Right? So thank you for the class, and learn all these methods. Do in your copy from starting to the end point, and you will be able to crack all the questions from this class. Okay. Okay. Thank you.